in section 5, we're going to go ahead and talk about systems of linear inequalities. So we've talked about a single inequality, but now we're going to look at a system. So when we're modeling with a system of linear inequalities, we're going to have two or more linear inequalities with the same variables. Now in section 5, we're only going to be looking at a system of two inequalities, but in section 6, we will take a look at when we have a system of linear inequalities that has typically at least 3 inequalities. So what you'll do is you'll then identify your inequality and the expression for each statement, and then your solution is now a region and not a single point. Because when we solved a system of equations, we looked for the single point of intersection. When we have a system of inequalities, we look for the region of solution. So there is more than one correct answer to a system of linear inequalities. And then in this case, all of our systems are going to be solved by graphing. So unlike when we solved a system of equations, we were using algebra, either substitution or elimination. With a system of inequalities, we are always going to graph. So you are going to be allowed to use Desmos to solve your linear inequalities. So let's go ahead and take a look at our first example. So we have Lars works as a nurse and a lumberjack. He wants to work for at most 6 days this week, and he wants to earn more than $950. He earns $216 per day working as a nurse and $112 a day working as a lumberjack. Write the system of inequalities that represents the solution, region, and graph, and then we want to answer the question, can Lars work as a nurse for 2 days and a lumberjack for 4 days? So let's start with what our variables are going to represent. I'm going to have X represent the number of days he works as a nurse, and Y be the number of days he works as a lumberjack. So for our first inequality, we are going to use the information that he wants to work for at most 6 days this week. So that tells me the number of days he works as a nurse and a lumberjack, X plus Y, has to be less than or equal to 6. For our second inequality, we're going to use the fact that he wants to earn more than $950, and the fact that he earns $216 per day working as a nurse and $112 a day working as a lumberjack. So that will have 216x plus 112y has to be greater than 950. So at this point, we would now graph this system of inequalities in Desmos, which is what I've already gone ahead and done here. You are not required to draw this graph in your notes. If you want to include a sketch of the graph, you're more than welcome to. So now I want to find where 2 days for a nurse and 4 days for a lumberjack would fall. So my x-axis is nurse and my y-axis is lumberjack. So I find the point 2, 4. Which is going to be right here. Now, my solution region, so the number of days where he can work to make enough money, is the region where they overlap. So that means the darker region. So if I'm looking, my darker region is in this triangle right here, which means any number of combination of days in that region is at most 6 and at least $950. So in this case, my point is not in that region. So the answer is no, and that would be because he doesn't make enough money. So even though 4 plus 2 is less than or equal to 6, so he isn't working more than the number of days, he's not making enough money, which is the problem. So for our second example, we have that Lane wants to buy milk and yogurt. She wants to buy a total of at least 6.5 gallons of dairy products and has a budget of $20. Write the system of inequalities that represents the solution region and graph. If Lane buys 4 gallons of milk, how many gallons of yogurt can she buy to meet both constraints? There is a typo here. It should say if yogurt here. And then we're solving for milk. So I'm going to let, so another piece of information that we need to know here is how much do yogurt and milk cost. So milk cost $4 a gallon and yogurt costs $2.50. So I'm going to let X be my number of gallons of milk and Y be the number of gallons of yogurt. So for my inequalities, we have that you want to buy at least 600 gallons of dairy products. So milk and yogurt are dairy products. So X plus Y needs to be greater than or equal to 6.5. Now we know how much each costs per gallon, and we have a budget of $20. So that means that 4X plus 2.5Y has to be less than or equal to $20. Because if I have a certain amount of money in my budget, that means I can't go over that amount of money. So if you graph that system of inequalities in Desmos, this is what we end up with. So we know our amount of yogurt, which is our y-axis. That is 4. So we need to figure out a amount of gallons of milk. So in my solution region, which is this triangle here, it's a very small area where I have a solution. Now, points on a line for a system of inequalities are allowed as long as both of your lines are solid lines, which means that both inequalities contained an equal to. On our previous example, one of our inequalities was a strictly greater than, which meant any value on that specific line wasn't part of our solution region. But because both of our inequalities here do have equal to's, then I can pick a point on the line. So there are a couple of solutions here where I am still in the solution region and I can buy my number of gallons of milk. So I can buy between, and if I'm looking at my scale here, that is going to be 2.5 gallons and 3 gallons of milk. So anywhere between 2.5 and 3 gallons of milk. And I will still meet both constraints. In our next problem, we have that a sundae requires 3 ice cream scoops and 4 strawberries, and a milkshake requires 2 ice cream scoops and 6 strawberries. Ray wants to make sundaes and milkshakes with at most 25 ice cream scoops and 37 strawberries. Write the linear inequalities that represent the amount of ice cream and strawberries that can be used, and then graph and determine at least 2 solutions. So we're going to let X be our number of sundaes and Y be our number of milkshakes. So my first inequality is going to be based on the amount of ice cream scoops I have, or scoops of ice cream. So you have a sundae that requires 3 ice cream scoops, a milkshake requires 2 ice cream scoops, and we have at most 25 scoops of ice cream. So that tells me that 3x plus 2y has to be less than or equal to 25. My second piece of information is based on my number of strawberries. So we have 4 strawberries for a sundae, 6 strawberries for a milkshake, and at most 37 strawberries. So that tells me 4x plus 6y has to be less than or equal to 37. So I've gone ahead and already graphed our inequality. So in this case, my solution region, which is my dark area, falls anywhere in this region. So I can pick any 2 points in that region. It does not matter which 2 I pick. So I'm just going to pick 2 arbitrary points. So there we go, 2 arbitrary points. So we can have our x-axis is sundaes, so 2 sundaes and 4 milkshakes. Or for my second example, I have that I can make 6 sundaes and 1 milkshake. Now obviously these are not my only 2 solutions. There are plenty of other ones, like I could make 0 sundaes and 6 milkshakes. Or I could make 0 sundaes and 8 milkshakes. There's plenty of different other solutions, but in this case I do have to make sure I pick only whole number solutions, because you can't make a decimal number of sundaes or milkshakes. Right. So for our last example, we have that Michelle sells laptops and smartphones. She wants to sell at least 12 devices and earn at least $4,500. She earns $425 per laptop and $125 per smartphone. Write the system of linear inequalities that represents the solution region in graph. Does Michelle meet both goals if she sells 9 laptops and 6 smartphones? So let X be our number of laptops and Y be our number of smartphones. So for our inequalities, we know that you want to sell at least 12 devices. So that tells me that X plus Y has to be greater than or equal to 12. I also know that she wants to earn at least $4,500, and she earns $425 per laptop and $125 per smartphone. So that tells me 425x plus 125y has to be greater than or equal to 4,500. So here is a screenshot of the graph, and we are specifically checking the point 9,6. So 9,6, it's very, very hard to see this graph, but it is right here. So just barely, but if you look at the shaded region, it does fall within our shaded region. So the answer is yes, she does. Please let me know if you have any questions about setting up a system of inequalities or graphing a Desmos and figuring out where your solution region is.